5.2, the power and polynomial functions. A power function is a function that can be represented by this equation. And in this equation, the k and the p are real numbers, and k is the coefficient. Hopefully you know what all those words mean. Alright, so the first example says, which of the following functions are power functions? So we're looking through this list and we want to know which ones are power functions. I'm going to give you just a second to think about that. Would you believe that they are all power functions? Let's see if we can write them in the form that we have in our general form at the top of the page. So a constant function can be written as f of x equals 1x to the 0. If you remember, anything to the 0 power is 1, and 1 times 1 is 1. So a constant function is considered a power function. How about the identity function? We could write that as f of x equals 1x to the first power. So that one is also considered a power function. And then we have the quadratic function. F of x is equal to 1x squared. We have the cubic function. These are pretty straightforward. F of x is equal to 1x cubed. But then we have the reciprocal function. Those are the ones most people seem to forget first. F of x is equal to, how do we write 1 over x with a power? If you remember, when you flip it over, it makes the exponent negative, right? So we have 1x to the negative 1 power. Then we have the reciprocal squared function. That works exactly like the last one. The function is equal to 1x instead of negative 1. This time we have negative 2. And then the square root function, that's equal to x to the 1/2 power. So go back and review those power rules if you don't remember some of these. The next one, the cube root of x, is x to the 1/3 power. So you can see that every one of these are actually considered power functions. Then we have the general shapes of power functions. Even powered functions and odd powered functions. You remember your square function? That's this green one right here. Hopefully you can see colors in this recording. This is your parabola right here. H of x is equal to x squared. Notice how whenever you change your function to x to the 4th, it gets a little steeper, but it also gets a little flatter at the origin. And then you look at whenever you change it to x to the 6th, it gets even steeper and even more flat at the origin. So that pattern will continue to happen the more you increase your power. Odd powered functions work the same way, except they're based on that cubic function. Remember that one? It makes an S shape and goes through the origin. Well, whenever you raise the 3rd power to the 5th power, do you see how it gets a little steeper here and a little bit flatter here? Same thing happens on this side. And whenever you raise it to the 7th power, it gets even steeper and even more flat. So odd powered functions are S-shaped, and even powered functions are parabolic. So then we get to talk about the end behavior of power functions. The end behavior is what's happening out here. Out here. Alright? So remember we said even powered functions are parabolic. That means it goes up on the left and it goes up on the right. What does that mean in mathematical terms? As x gets bigger and bigger, so x is going this direction, y is going this direction. So as x gets bigger, y gets bigger. That's what this one means. Oh, sorry, that's what this one means. This one says negative infinity. So as x gets smaller this direction, y gets bigger. As x gets smaller, y gets bigger. That's what that means. Okay, so let's look at the odd-powered one. The first one is negative. We'll do it the right way this time. As x is getting smaller, what is y doing? As x is getting smaller, y is also getting smaller. That's what this line right here means. As x is getting smaller, going to negative infinity, y is also getting smaller. That should be negative. That was a typo. Sorry about that. The next one says as x is getting bigger, what is y doing? As x is getting bigger, y is going to positive infinity. I actually copied this straight out of the textbook, so I'm really sorry about that. I'll have to contact the writers of the textbook. So let me just make sure I didn't say that wrong. As x is getting smaller, y is getting smaller. As x is getting bigger, y is getting bigger. Alright, so what happens if you have a negative constant? If you have a negative in front of your function, like f of x is equal to negative 2x squared. Remember, that means it flips it over, right? So in this case, as x gets smaller, y gets smaller. That's what this one says. As x gets smaller, y gets smaller. The other side says, as x gets bigger, y also gets smaller. So this is true for this one. As x gets bigger, y gets smaller. And what about the odd powered with the negative coefficient? It's a reversed, or it's reflected over the x-axis from this one. So if you flip this over the x-axis, you get this graph. That means as x gets smaller, y gets bigger. As x gets bigger, y gets smaller. So let's look at an example. Describe the end behavior of the graph of f of x is equal to x to the 8th power. Well, x to the 8th power is even. So the graph is similar to the parabola, or the U-shaped graph, but it has what at the origin? It gets a little flatter. Okay, that's how you could describe the middle part, or the whole look of the graph. But what happens as x gets bigger? This is a positive x to the 8th, so it's something similar to this one. As x gets bigger, y also gets bigger. As x gets smaller, y also gets bigger. So you could say up on the left, up on the right. How about the next one? Describe the end behavior of the graph of f of x is equal to negative x to the 9th power. So this is an odd powered function, so we think this, but since it has a negative in front of it, it's actually this one, not this one. Alright, so whenever you draw like a general form, it can help you with these other pieces. The graph is similar to the cubic graph, or you could say it's similar to the S-shaped graph, but it flattens out at the origin, or you could say it gets flatter. Okay, so what is happening as x gets bigger? As x gets bigger, y gets smaller. And what happens as x gets smaller? As x gets smaller, y gets bigger.